Good afternoon. My name is Dr. Ariel Santos. I'm the Director of Telemedicine at Texas Tech University Health Sciences Center. And we are honored and grateful today to have Dr. Sanjay Subramanian, who will talk about the distress system, the National Emergency Tele-Critical Care Network. Dr. Subramanian is an experienced critical care physician with proven accomplishment improving clinical quality in the ICU and developing tele-ICU programs in numerous hospitals. In addition to teaching and practicing at the bedside, he has a keen interest in application of technology in the ICU. He's the past chair of the Society of Critical Care Medicine subcommittee on tele-ICU. He is an associate professor of critical care medicine at Washington University in St. Louis, and is also the founder of OmniCure. Today's webinar is sponsored by TexLa TRC, a federally funded program supported by HRSA and the NTRC. Unfortunately, we don't have CME for this activity. And we would like to remind everybody to keep your microphone at mute, and there are options to change your screen. And also use the chat feature if you have any questions. My colleagues at the Society of Critical Care Medicine section of surgery, patient safety committee is very interested in this topic. Those colleagues who are interested in disaster management is also interested in this topic, and we will have this webinar recorded. Without any further ado, I would like to give you Dr. Sanjay Subramanian.
Good afternoon, everybody. Thank you, Dr. Santos, for that wonderful introduction. It's a pleasure, a privilege to be invited to give this lecture on the distress system, which is part of the National Emergency Tele-Critical Care Network. I'm going to start by sharing my screen, and hopefully there'll be no technical glitches. Okay, so I'll have to have somebody disable on your side. Okay, there we go. Okay. All right, can everybody see my slides?
Yes, sir.
Okay, perfect. So as Dr. Santos said, the distress system, it's an acronym for telemedicine response for emergencies. It's part of the vision of the U.S. government to have a national emergency telecritical care network. So as you all know, 2020 was a pretty eventful year for all of us critical care physicians, and it's really highlighted the fragility of our nation's healthcare system. It has clearly demonstrated that we struggle to respond to pandemics on a national level because of numerous reasons: maldistribution of resources, because of maldistribution of providers, inadequate access to resources, and the fact that we just don't have an infrastructure in place to rapidly onboard and recruit critical care providers on a large scale to handle a surge in cases in the ICU. So as we all know, telemedicine is really a force multiplier, and I think everybody has used telemedicine, I think, these days in some format. It's a technology that enables expertise to be leveraged over a large area, geographic area, and over a large number of patients as well. Now, it's clear that obviously pandemics require agile solutions. The traditional model of a point-to-point telemedicine system is not pandemic ready. It's not something that can be scaled rapidly, and it certainly has limited scope in such situations. So based on the fact that what we need from a telemedicine perspective for pandemics is so different, the government put out a request for proposals for such a network that would actually enable to be rapidly stood up to meet the needs for in the times of disasters and pandemics. Now, as we know, in disaster situations, technology can be used in a wide variety of fashions. For example, by using virtual clinics, you can take the expertise right to the patients directly in their homes. It can be direct to consumer. Or another scenario could be the concept of a virtual hospital, where you have providers, who are skilled, have access to all the expertise, but they are in a remote location, and then they can leverage their expertise to providers who are less qualified in other settings, maybe in rural hospitals or smaller situations, where these physicians can then be supported by remote experts using technology such as telemedicine. Take it one step further. You could even potentially envision the case of a situation where perhaps remote providers who have access to autonomous systems and remote control devices, for example, could even potentially intervene and make changes in real time to devices that are not even located in the same building. So clearly, technology can have a lot of applications in such situations. Now, the other thing that's important when you need to talk about technology applications for on a large scale is that you need to have adequate access to data. When I say data, it means situational data relevant to individual patients for the clinicians, but also more high-level aggregation of data from multiple sources, which will help inform overall situational awareness. So it'll give you an idea of the overall system's efficiency, an idea of resources, an idea of capacity, idea of utilization on a much broader level. So these are sort of the ways in which technology can really be utilized for disasters. To some extent, this has happened in a limited scale, and I've listed some examples in purple at the bottom where some of these applications do sort of cater to this need. But what the NET Center, which stands for the National Emergency Tele-Critical Care Network, it hopes to do sort of to establish a sort of a national infrastructure for this sort of for this vision, and that's the whole idea of this project. The next slide, again, it just talks about these. What I talked about in the previous slide was the concept of virtual clinics, virtual hospitals, and how these can actually help take the healthcare right to the patient in their homes or to hospitals in remote locations. I think we realized that, when we were overwhelmed by COVID, a lot of the patients, showed up in hospitals. Some of them needed to be admitted. Many of them perhaps did not. And perhaps some of them could have been managed at home. Now, in the absence of infrastructure which allows safe monitoring of patients at home, so-called, the concept of a hospital without walls, which is fast becoming a reality, in the absence of an infrastructure for something like that, we were not able to do that, right? Which is why hospitals got inundated with patients. Providers were stressed beyond their limits. It led to a lot of burnout, emotional burnout, and patient care, frankly, was at times unsafe because we did not have a safe way to leverage expertise across the huge population. So I think this clearly has demonstrated a need for creating a national system that will, if not one system, at least a system of systems that will support this sort of care model in the future if there were to be another pandemic or a natural disaster. By the way, if anybody has any questions about anything, please do feel free to raise your hand or stop me. I don't want to make this as interactive as possible. So the idea of the excuse me, sorry, I need to go back to the previous slide. Whoops, this is really going too fast. So the idea of the distress system, which is part of the National Emergency Tele-Critical Care Network, is a little bit different as opposed to the point-to-point care model that we are so used to seeing in telemedicine. This is more of a aggregate data approach as opposed to an individual point-to-point delivery of healthcare. So the idea here of this is basically that you use multiple data sources from patients, from traditional data sources, from bedside monitors, medical record systems, and including novel data sources from things like wearables and sensors, et cetera. And all that data is transmitted to the cloud and hosted in a cloud-based solution into which numerous applications can then be interfaced and which can then be used to provide the appropriate support and expertise for care of patients at homes. And then the same data can also be used by administrators and leadership individuals to look at the whole situation and situational awareness. Obviously, it's a pretty ambitious model, and it's going to be implemented in a small series of steps. And what I hope to show you today is, how much of that has happened so far. But really, at a high level, the idea is that all the data is hosted securely in a cloud into which multiple applications can tap into or interface into, and then that data space becomes the source through which telecritical care can be provided to a large swath of population across multiple institutions, as opposed to the more traditional point-to-point individual siloed network. So this is more of a network-based approach to telecritical care across a wide variety of patients, as opposed to the more traditional point-to-point individual networks. So as I said, I think the distress system or the NetSyn system is more of a system of systems. It's a distributed care provider network supported by multiple teams and multiple vendors of telecritical care. The system requires or is required to be mobile, flexible, rapidly scalable, and rapidly deployable. Clearly, the traditional models of telecritical care, which is very hardware dependent, is not something that is, although it has been used fairly effectively, I would say, during the course of the year for COVID. It's really not the ideal situation because, number one, it's not rapidly deployable. Number two, the cost of scaling up is quite prohibitive. So you would want to have a system that is, much more flexible and uses more ubiquitous technology. For example, smartphones and mobile devices, which are far more ubiquitous than telemedicine cards and fixed cameras, right? So the idea of the NetSyn is to sort of promote a safe system that is scalable, but yet deliverable through ubiquitous technology like cell phones and handheld devices. The technical infrastructure of the system must facilitate the use of multi-vendor solutions to deliver capabilities for telemedicine, for telecritical care, for remote device monitoring, for documentation, for control of systems, and as a futuristic vision, even evolve into a more of a semi-autonomous or perhaps even a fully autonomous system that would rely on automated algorithms using machine learning and artificial intelligence to drive patient care. So a little bit about the history of this project. Sorry, was there a question?
Oh, yes, sir. I just have a quick question on the previous slide. This is an ideal one wherein all vendors could potentially interface to each other, essentially talk to each other, so we don't need to repeat a lot of diagnostic tests or a lot of workup that has been done in one institution. My question though is in some areas, especially here in rural Texas, wherein we have sometimes problem with broadband and internet connectivity. Will this potentially be a problem as well, since this is a cloud-based?
So the system relies only on, as long as you have 3G or above, as long as the data can be transmitted through your cell phone device, as long as it's cell phone capable, that is sufficient. So you don't need necessarily high fidelity networks for the system to operate. Perhaps the latency and those things might be affected by the absence of a high speed network, but the system itself will still function. As I'll talk about the data architecture, you'll see that it will allow for this to work even when you don't have of course you need some level of connectivity. And part of the project also involves, how to design redundant and backup systems so that if you lose connectivity, say in a natural flood or a disaster, and all cell phone towers are down, then how can you, potentially stand up like transmitters, by maybe shipping them to that affected area quickly and then activating the system. But those are all, next steps. But But you're right, there can be limitations with limited connectivity. But in this instance, as long as there's at least 3G, this system should work. And I'll talk about your point about multiple vendors, about the issue of interoperability. It's one of the last slides. I talk about how we are hoping to address that as we go forward. So in terms of the timeline of this project, this was actually released soon after the COVID pandemic hit. So the government released a request for project proposals for this to come up with a proposal for how such a network might be stood up. It was a competitive process where I think initially there were almost like 80 or 90 companies or 90 groups of companies that actually applied to help develop this solution. And the distress team, and I'll show the names of the different entities on the distress team that was one of the teams that is now in the final phases of helping develop this solution. So there was a series of so the first piece of the proposal was to submit a white paper, an extended white paper approach, which was evaluated by the government, by subject matter experts. All the proposals were ranked in order of merit. They chose initially 9 teams. From 9, they moved on to 4 teams, and 9 to 6, and then eventually to 4. So the final system will probably have 4 vendors who are going to be working very, very closely. I shouldn't say 4 vendors, but 4 solutions that are going to be, working very closely with each other and interoperable. And each of them would have a lot of similarity to each other, because at the end of the day, the solution that we're proposing is designed for this specific use case. So the phase 1 of this project was kicked off in June of 2020. The whole approach was that of very rapid sprints with very defined deliverables, and to develop prototypes and MVPs in very short order, and show that back to the government with feedback, and then continue to evolve the product into a near final phase. One of the important things that happened along this project was in December of last year, the project, which was initially funded and supported by the U.S. Army, Department of Defense, signed or by TATRIC, which is the Telemedicine Technology Research Center. So they're the ones who started the project, but then that was there was an MOU between them and Aspirin Health and Human Services. So that obviously gives a more sustained support to the project, if you will, to allow it to sustain beyond, just even the pandemic. So that's the idea, is that this would be a long, sustainable solution that could benefit the nation in years to come. So right now we're in what we call the phase 2 of this project. Phase 1 being development of the initial clinical prototypes and deployment, and supporting hospitals to deal with COVID. The phase 2, as it pertains to this project in 2021, would involve essentially getting ready for clinical scaling to involve potentially the entire country, or to be available to institutions across the country, along with enhanced functionality, and to also complete the integration with additional external data sources, as well as implement interoperability between the different solutions within the NetSyn system itself. One of the other components is, of course, to have a high level of security around this whole solution. So the FedRAMP process, which is a very stringent security measure or cybersecurity protocol and system, will have to be implemented as part of this in this year. So as I mentioned, so the distress system, more specifically, it's a comprehensive, mobile-friendly, scalable telemedicine response system for disasters or pandemics, to provide urgently needed expert support during COVID and even otherwise. The system is supported by a nationwide network of intensivists and other specialists, potentially, to provide immediate consultative support for cases regardless of where you are. So as opposed to relying on your own network of physicians or within your own institution, the idea here is that you just are able to access the system. And as I'll show you, it's essentially, it's a downloadable application that allows you to potentially get in touch with the intensivists, a network of intensivists who would then provide support. It's a completely decentralized model, as opposed to the hub and spoke model, which is quite common in many telemedicine systems. This is very different. This is intended to be a network of providers. It's a decentralized model, and as we implement more features into the solution, there will be algorithms that will facilitate more optimal matching of supply and demand. So if there's one region that has, more cases and more requests for support, then those are automatically routed to providers that have excess capacity at a given time. So those sorts of algorithms will be implemented in the back end so that every provider who's in the system, or every remote specialist who's in the system, can respond to questions or queries in real time more effectively. As I mentioned, of course, this is intended to be a cloud-based solution, okay, with elastic limits, and that's one of the earlier as well, that the intent is for it to be rapidly to be capable of rapid implementation. So it would be device agnostic with minimal hardware requirements. So all you would need technically is a cell phone. Okay, so that's
where do we get this network of intensivists? Is this in collaboration with Society of Critical Care Medicine, or is it a private institutions?
So no, there's not. Yeah, so it is essentially a volunteer group. So then the volunteer group comes from, like, for the distress system. Our pool of volunteers is from many different places. So we have volunteers from physician services companies, from the Society of Critical Care Medicine, from academic institutions. So really, the pool is really it's a potpourri of different types of providers. So it's not. And I'll mention this briefly, but there's going to be soon even a website launched through which providers can enlist themselves for support to be part of this network. So the idea is that it will be a completely national network of providers. Okay, does that answer your question?
Yes, sir. Thank you.
Yes. So a little bit more about the team. The distress solution was actually jointly developed by a number of institutions, as you can see on this slide. The Geneva Foundation is a nonprofit organization that helped to facilitate the entire process and the contracting process with the government. And they're located out of Washington State. The Madigan Army Medical Center is obviously a military hospital, and the distress team is also comprised of Omnicure, which is a telemedicine, and I'll talk a little bit about the telemedicine or Tele-Critical Care application component of it. In addition to that, the Society of Critical Care Medicine also contributed its expertise and resources to help with the initial prototyping of this solution by providing volunteers to help with testing, etc. DocBox is a device aggregator. So essentially, what this particular device aggregator does is it's able to in real time obtain data from bedside devices, ventilators, bedside monitors, everything. And in real time, make that available in a normalized fashion via the cloud. And I'll talk about the architecture in a little bit, via the cloud, through which an application such as Omnicure, which would be the application through which you can view that data. Okay, so that's what DocBox would do, and we'll talk more about that. This is the telemedicine research for operational support. The TRFOS is another institution, again located out of the Madigan Army Medical Center. It's a research lab that helps us test different scenarios, help us to do simulation testing. The MDP&T lab is located at Harvard, and it helps the team with testing interoperability situations, to help also to potentially, as we go along, to test the capabilities for autonomous control of the system, etc. So as you can see, it was really a very diverse group of people that came together It was not just one entity or one company. It was just a very diverse group of people that collaborated together to help with this solution. So in terms of the system architecture, so really there's many components to it. So on one end, you have the application, the telemedicine application, which is the front end or the physician facing end, which is the mobile telecritical care, TCC standing for telecritical care platform. Then behind that is a medical IoT platform, or ICE, which is called the integrated clinical environment, which is the virtual data space into which all data feeds. Okay, so that's one portion of the backend, and then through that you have there are many open patient data APIs which interface with individual data systems at patient level, institution level, data repository. There's a data repository in this system that is based on open standards and with a robust data dictionary as well. The idea of a master patient index, which you can see over there, is that you would not have to rely on a medical record system or an EMR to create a unique patient entity or an encounter. So as patients become part of this network, they each get assigned a unique patient index, okay? And as they move through the system and eventually maybe show up in a hospital or go from one hospital to the other, that master patient index goes with them. So data for that patient is identifiable through that same index as the patient moves through various locations. And I'll talk a little bit more about that. The idea of the system is basically to enable teleconsults using a combination of telecritical care and real-time bedside device data, which is very similar to what telecritical care does today. However, the difference here being that this is a decentralized system as opposed to the more hub and spoke model. In addition to that, a component that's somewhat unique is the capability of integration of medical devices and sensors such as wearables, wellness monitors, smart watches. Today, the system is capable of integrating with a handful of medical devices. I shouldn't say medical devices, wearable devices, through which data, for example, your heart rate or your blood pressure could be visible on the telecritical care application on the mobile device for the remote provider. But the vision as we go along is essentially to have a complete ecosystem of wearables, so that multiple devices, no matter, depending on what the patient might have, can constantly send data to this virtual data space through which the application, such as this telecritical care application, can then look at that data and then use that data for meaningful decisions. This data, of course, can be aggregated not just for research, but also allow the different telecritical care systems to interoperate to share such data. I didn't mention this in the slide, but part of this NetSyn program also is to feed all the data that's coming in from patients to a data commons, obviously in a de-identified format, but that data commons would then be utilized by the US government for future efficacy research, et cetera.
Dr. Subramanian, there's a question in our chat box. It says that, we believe that the data belong to the hospital or hospital system. How does the program intend to overcome this problem?
Yeah, so I think the data still belongs to the hospital. So whatever is shared with the government is through a shared agreement. It's a restricted data use agreement, where it's de-identified and it is not necessarily owned by the government, but it's what is shared with the government is data that could be used for efficacy research, not actual PHI.
Gotcha. And the other thing that we should mention about wearables. So these wearables will be provided, by the government, I guess, whenever a catastrophe or disaster or emergency occurs.
Yeah, so I think the government has not made a choice, because this is a very crowded space, right? It's clearly a very huge commercial opportunity in the wearable sector. The government has decided to be agnostic. They have said that for example, this stress team, that you have to just be capable of integrating with wearable devices. So they've not, I don't think, and they probably won't ever select a single wearable device to be used by every patient. It's not going to happen. But the idea is to create an ecosystem that you can get data from multiple wearable devices. Now that said, there are already, there's, for example, a company that that we work with. They actually already integrate data from multiple wearable devices, glucometers, blood pressure monitors, temperature probes, etc. So they already do that, and then they provide the APIs. So in our system, the Tele-Critical Care application, or the web or the mobile application, would talk to that API and get the data for that patient, depending on no matter what that wearable device could be. So there's not a notion of one wearable device that's going to be required by the government for being part of this network for the system. I think they realize that it's going to be a multi-vendor solution, so they have to learn to work with each other.
Gotcha.
So this again is just a high-level schema which kind of shows you how the system might work. So you have data coming in from multiple sources. So you have data from wearable patient sensors, and you have real-time data from patients across different locations in hospitals and clinics, wherever have you. And then this data is all eventually able to be used by providers in a scalable fashion, in a dynamic, scalable network of healthcare providers. And the model obviously fundamentally relies on using mobile capability as opposed to the traditional hub and spoke model of delivery. So essentially, as you can imagine, the idea is to have a platform that has many applications. So in terms of use cases, we talked about patients in hospitals, but clearly this is obviously capable of taking care of patients at home. Okay, the idea of hospital without walls can be used by emergent EMS providers. Obviously, there's a lot of interest in avoiding unnecessary hospital transfers by EMS folks. So foreseeably, if you have patients at home that have a situation, the EMS provider shows up and they're not sure the patient needs to go to the hospital or stay at home. Well, if they're able to hook into the distress system, they would get a provider, an expert on the other end, who would say, okay, the patient can be at home, for example, but you need to do X, Y, and Z. And the patient has a remote, for example, a pulse ox or a remote device that is part of the distress wearable ecosystem. Then the remote provider could continue to monitor that patient even after the EMS services leave. So you could potentially avoid unnecessary hospitalizations and exposure of patients to hospitals in that fashion. Clearly, this obviously has an application for any other inpatient setting, for emergency room consultations, for appropriate triage of patients to the right level of service. And of course, the bread and butter is still the consoles within the ICU environment itself to help support patients in the ICUs as well.
Dr. Subramanian, there is a question on our chat box. I think they're just kind of worried because not everyone could afford the wearables. I myself don't own a Fitbit or whatnot. So dependence on the wearable will already eliminate a large segment of the population if not provided freely to the people. So, there's now a question of, equity and whatnot. Then
that's a very, okay, please go ahead. Sorry, finish your question.
Yeah. And the second question is, does this network then have an on or off switch? Who will control the switch? Is it the government, the feds, the state, region, municipalities? In other words, who will define when there is a distress and turn on the network?
Yeah, excuse me 1 second. The light went off in my room. Hang on for a second. I think it's very sensitive to movement, so I wasn't moving, so the thing went off. I gotta keep waving my hand on one side to make sure the light doesn't go off.
I thought you went in a black hole, sir.
Well, I know my screensaver looks like the stars and everything, but yeah, I think those are very, very valid questions. I mean, I think so clearly the project is an evolution, and we meet the government nearly every week to talk about the project and the direction it's going to take to come up with the answers to hard questions like these. You're right. Nobody should be left behind because of reliance on a wearable device, right? I completely agree with that. So I think what they're trying to do is address both ends, So for the vast majority of population that is already hooked into wearables and wants to continue to use them as the source of their healthcare data, we need to be able to tap into that. But then there's a huge segment that may not afford wearables. So in that case, then the idea is that you at least provide them a way to at least connect to a provider, So the Distress app is not going to be accessible only to somebody that has a wearable device. It's an application you can download from the cloud. So if you're a patient who doesn't have a wearable device, you can still access the application. There's no charge to download, it's all free. And if you're a patient at home, you would be able to send your questions or queries, and some provider will be able to at least guide you through the process. Maybe it involves dispatching an EMS to that patient's home because he doesn't have access to any sort of monitoring device. But these are very, very good questions, and I'm not sure I have the answers for all of those, but I think certainly it's something to be thought about. Maybe depending on how much funding the government decides to allocate to this, maybe one portion of this should be that perhaps there needs to be a system of wearable devices that is subsidized or highly subsidized for people that can't afford it. And then that would make the whole system more equitable. Yep, that's a very good question. Thank you.
Yes, sir. And the other thing, though, is to piggyback on that question is the digital divide among, the elderlies. There are, sector of our population that is really not very good with technologies. And so there's a little bit of digital divide with that.
Absolutely. And I think one of the things that we, and obviously I'm not going to show all the details of how all the apps work, but there's, when you download the app, there's a questionnaire. I mean, if you're an elderly patient, the idea is that you could be the patient or you could be a surrogate who would then download the app for you. Like, your mom's at home and I want to still access Distress. So I would access the system for mom, okay? And then you would be the person, acting on her behalf to help support her healthcare needs. So yeah, but these are all very questions. So that's why I think, in terms of large scale scalability, I think we're still at least a couple of years out. So that's what this whole phase 2 is we're talking about. I mentioned the scalability. These are all the issues that need to be addressed. And that's why it's nearly almost a 2-year long endeavor from this point onwards. So we dealt with the initial COVID surge, but then we need to have a sustainable system, right? And future scalability has to take into account all the exact same things you just mentioned. So in terms of a little bit more about the actual the mobile application, or I call it the TCC platform. So the application essentially has multiple components. In terms of functionalities, as I mentioned, it provides access to a virtual network of critical care experts using a real-time dynamic recruiting process. What I mean by that is, as a provider, if you're interested, and if there's a surge, for example, and you want to provide your services to a population in need, you would simply download the application. And if you're a remote doctor, you would just say, okay, I'm a remote provider. I don't have an account. I want to sign up to provide help. Okay. So you provide a series of responses to some basic questions, obviously your name, some basic information like an NPI number, and then there's a rapid vetting process that matches the provider's credentials against the database. And through that, the provider will then be able to get an account in real time, through which then he or she can then help support the patient anywhere. So it's potentially as simple as that. There's a virtual command center role, and that's the center point through which all these back-end functions happen, where providers' credentials are validated, vetted, the accounts are assigned in real time, and this is how the onboarding occurs. As I mentioned, the system is intended to be decentralized and distributed, right? So the idea is that there's a network of providers, not necessarily in one geographic location. Of course, we are making the assumption that providers in the case of a pandemic or disaster scenario are not confined to practice within state lines. So we're assuming that that's already taken care of. So if that being the case, any provider is able to respond to a consultation request that comes within the application itself. There's a feature within the mobile application that allows a a bedside person who's requesting help to you potentially alert all remote providers for an emergency situation. So example, and this could be very useful where, where there's an ICU is overwhelmed with a lot of sick patients and they simply don't have time to, call an individual provider or to type out a detailed consult, but they just need some help. So the SOS feature in the application also allows multiple providers to be notified simultaneously, and anybody can actually respond to that. So it has many different functionalities. I've just sort of highlighted some of the ones that I think could be interesting or useful for people to know about. And we'll talk more about some of these features. Whoops. Here. So the other features of the Tele-Critical Care platform itself is that, the backend logic or the algorithms that are being developed and that currently exist allow the critical care professionals, as the medical demand surges, the application, incrementally will dynamically recruit more and more critical care providers. In other words, there's potentially 50 people have signed up, but not everybody is active on the application. Now, you have a certain bolus of patients, then the system will start notifying providers who are in a dormant state, if you will, or not actively logged into the application, saying, hey, there's a need for another 10 doctors. Are you able to log in and start providing support? So there's that backend logic that that the system will have to allow efficient matching of supply and demand. There are some other features within the application itself that allows one provider to transfer his patients to another provider at the end of his shift, for example, or when they are overwhelmed. So there's a dynamic handoff that can happen. So if you're working on a case, but you're too busy and I want Dr. Santos to take my case, I can just hand off from within the application and then he would start picking it up. So this really kind of, if you will, it really disassembles the current paradigm of care. The associations are somewhat loose, if you will, but they're designed to be loose because that's the only way you can actually flex and scale in the case of a pandemic. One of the requirements, of course, for this platform is that all the communications should eventually be sent back to the patient's medical record system. So that goes through the FHIR or HL7 interfaces back to a hospital's medical record system. So as the patient, for example, may be in a small hospital, rural hospital, and then the system is activated to help these patients, but eventually they move to larger tertiary care centers. All the data that's accumulated when the patient's at the first location should not be lost when they move to the second location, right? So the idea is that this data that is all generated when the patient's at one location A moves with the patient to location B. It's sort of similar to what medical record systems are hoping to do, but this is, in the context of telecritical care. So as I mentioned, there's the opportunity for shift management and handoff all through the same mobile application itself. So again, this is a little bit of a cartoon that shows the architecture of the distress system, if you will. So there's a telecritical care platform in the in the center, which helps collect all the data from bedside devices, monitors. It has features which includes the real-time messaging between providers, audio video calling, which is the telemedicine component of it. And then through integration with the EMR through FHIR or HL7, the data can be sent back to the hospital medical record systems when the patients eventually do go to a hospital or depending on where they're admitted. On this side, you see, on the right side, you see the remote critical care teams. And like I mentioned, it's a network of providers, not providers in one specific location. The data from the application eventually, and I'll show you a screenshot of that, it feeds a system dashboard and analytics dashboard through which you can look at system efficiency. So a little bit more about the mobile application itself, and I just wanted to show this because it shows some of the features that are there within the application. So the idea is that there's, you would download the application, okay? You'd be able to enter the patient's, if the patient is not in the system already, you would enter the patient's name in real time, and be able to request a consult. That consultation or request for help is visible to all remote specialists in the network. So anybody can respond to that, as opposed to the more directed consult request, which in many of the consumer-facing apps, this is different. It's intended to be a distributed model. So anybody who is available in the remote network can respond to a question. In the most austere setting, you would just have access to the patient's name. You would have access to his communication data, okay? And you would, the patients in a rural clinic or in a remote setting, you would maybe just have a set of vital signs. But the application also has some features which allows the two providers to communicate using text, audio, video, and also even to send files, pictures. For example, all you have is an EKG from a rural hospital or some basic lab work done at a rural clinic, and you would just have a picture of that. So the idea is to enable the most basic type of communication to the most sophisticated type of communication through advanced interfaces where data is streaming live into the application. So that's basically it. So this cartoon on this side, and when you look at it, you'll see that it's showing how the workflow happens. So how the consult is generated, how someone can look at the patient details, how the consults are organized as active or pending. There are features in this. For example, you can flag the urgency of a consult as well. So the bedside providers requesting for help can actually flag the message as urgent or a consultation as urgent within the system itself, and that leads to a little bit of a notification on the consult where the remote provider knows that the consult's urgent. In addition, there's also a basic decision support tool. There's a score called the News score, which using the basic vital signs itself, it calculates an acuity score. So as a quick look for the remote provider, he would be able to know how sick the patient might be. So really the idea of the Tele-Critical Care platform is to provide quick access to expertise to support hospitals, clinics, and patients across a wide variety of settings. And the system is intended to be flexible, okay, and also to be very easy and intuitive. And in fact, the whole idea of a messaging feature within the application itself is to give you that comfort of a FaceTime-like communication. Of course, this is not FaceTime, this is not WhatsApp. This is, of course, a HIPAA compliant secure platform. It's not like any loosey-goosey texting app. But that's the idea, is to allow structured, streamlined medical communications in the context of a given patient. So I talked a little bit about, so that's a little bit about the the front end, which is the mobile application. But on the back end, of course, as you can imagine, there's a fairly complex architecture which involves data from multiple sources. I wanted to bring up the concept of what we call an integrated clinical environment, or we call ICE. So the idea of ICE is basically it's a distributed and scalable IoT platform that connects to multiple devices. So bedside devices, ventilator data, etc., monitors, body sensors, infusion pumps, and what have you. The idea is that all that data is aggregated in real time into one environment, as opposed to being siloed and isolated. It's aggregated into one environment, normalized, and then the idea is that multiple applications can then tap into that same central IoT database to get the data that they need. The ICE environment essentially collects, aggregates, normalizes, and stores all the real-time data at the bedside on a data cluster. And I've mentioned the name of one common data cluster architecture that is used is Hadoop. You may know about it, but that's the architecture that's used in the distress system, for example. This data is then communicated in real time to a virtual data space, or a Tele-Critical Care virtual data space, which is how the end user would be able to see that data on their mobile device, for example. The idea is that the data can flow to both Tele-Critical Care applications and simultaneously to regional and national reporting dashboards. So the idea is that by creating this environment, multiple telecritical care sites with multiple types of vendors could actually consult on the same patient, both simultaneously and asynchronously. And this kind of graphic explains this sort of data structure of the whole system. So, so they have, there's a global data space here for telecritical care. It gets data from real-time networks, from patients, and it all goes to the cloud. And and as you can see, the information is bidirectional. So obviously, you can have multiple users tapping into the same cloud to view the same patient data. So you go from, from single-level patient data to more groups of patients data, which helps create situational awareness and operations data for each location of care. And then as you get into deeper into that, you could generate the appropriate staffing loads and patient ratios and determine clinical responsiveness. And you use that information to determine your staffing, and you create the appropriate balances in staffing to help deal with the clinical load. And then by aggregating all the data into this one cloud, you can obviously analyze, your common metrics like length of stay, on a granular level, the things that, that you and I do routinely, looking at length of stay, length of mechanical ventilation, et cetera. But is just to be able to do all that from the same source. And then in terms of telemedicine capabilities as well, the idea is that when you create this, what we call a virtual data space for telecritical care, it allows multiple telecritical care applications to access the same data and be able to provide telemedicine to patients. So I've just given 3 examples here of, you could implement this for an existing telecritical care center by simply allowing access to the distress cloud. You could implement this ad hoc in a senior living center or a point of injury care for patients at home or in clinics, for example. This is a picture of what the command center looks like. It's essentially like a dashboard, basically. And right now, this has data from the mobile application, which tells you at any given point how many consultations are being requested, how quickly those consults are responded to, what is the geographic distribution of these consults, where are they coming from, who are the patients that are being consulted on actively, what are the pending consults. So a lot of operational data exists in this dashboard at this time. It also gives you a look into your into your staffing model, how many physicians are available online, how many are offline, etc. So it's essentially an operational dashboard. In future state, this will be integrated into more complex dashboards, which will also feed in data about resource availability and capacity from hospitals, for example, bed availability, et cetera, et cetera. So, but this is the beginnings of that. So the idea of the dashboard is to allow for, near real-time data-based patient risk stratification, to help track resource utilization, to help track key metrics such as case volumes and provider responsiveness, and also to visualize regional differences in patient volume and acuity. So I just thought I'll go from there to kind of give you some examples of the workflows that you might encounter when you're dealing with COVID or pandemic, and how this system might actually function. Before that, were there any questions in the chat box? I've not been looking at it.
There's a question regarding, I think, it seems like the system is really dependent on new kind of physician, one whose education is heavily concentrated on treating remote patients with remote equipment. Alternatively, why can't the system develop and then rely on the AI physician?
So what was the last sentence you said? I'm sorry.
The last question is, why can't the system develop and then rely on the AI physician?
I mean, that's the direction in which it will go eventually. I think right now we're not there. to develop, I'm sorry, to go there, I think you need more data to have a, because to develop AI algorithms, you have to first, create the model, test, validate, and then implement. So for that, you need more data. So I think the system is fairly new. So I think once it matures and there's more real-time usage data, then I think that's the direction in which this will eventually evolve. And that's part of why, I think I mentioned semi-autonomous and autonomous systems, is that this was, so a lot of the triaging, for example, it need not be manual by a provider. Based on the symptom questionnaire that the patient fills out, hopefully the system can eventually help triage the patients, satisfactorily. There still has to be some balance checks and balances, but that's the intent of the system. But for that, it'll take some time for the system to get enough data and mature so that we can implement these AI-based algorithms, without any risk, or with less risk, I should say.
It seems to be the future, Dr. Subramanian, where they will give you the data, then the drip will change, the ventilator will change automatically.
Believe me, that's happening. That's the next phase, in fact, is to test how you can remote control a ventilator. And how you can remote control an infusion. That's the part of that, I mentioned the MD-PNP lab as part of the team. They do that. They actually play around with all this. So part of this would be me as a critical care doc, log into my phone, find a patient. Okay, I don't like this vent settings. Can I just use my phone as a remote control and change his vent settings from where I'm sitting?
That sounds to be exciting, yet scary as well.
Right.
It's a wild concept, but nevertheless, it's something that is being looked at. And that's part of what the next phase of this project is going to be. Yeah. So in terms of, the workflow, just at a very basic level, how does the system actually work? I know I said a lot of foo-foo things about the data and cloud and this and that, but how does it actually work,
Technical terms.
Technical terms, but yeah. But I think essentially what it is, there's, you have a bedside provider who's struggling. He's a hospitalist. He has 20 COVID patients on the vent on Optiflow. He doesn't know what to do. Well, he downloads a smart app. Okay, the wards have iPads or tablets with the app downloaded. Okay, you create accounts instantaneously. Like I mentioned, the accounts are created. Your bedside provider would put in a consultation request. There's a remote team of providers who are available. They're looking at their cell phones. They get a notification saying, okay, so-and-so doctor in Lubbock, Texas is in trouble. Okay. So then they respond to they accept the consultation, and then next thing you know, you can initiate the video call, do the audio call. And then if you want to get more information, over time, you can integrate with the EMR of the hospital system and look at all the data points. But finding an intensivist should not be hard. That's the whole idea of the system, okay? Is that it should be easy. It should be as simple as just downloading an app and putting in your request. So that's the fundamental principle, is that all the other stuff is great, but at the end of the day, its access to the intensivist should be easy. And that's what the system is designed for, is that it provides an easy way for you to get in touch with an expert so that you feel reassured and not out of your comfort zone when you're handling all these patients. And then over time, of course, as a system is implemented in a more sophisticated way, you would have the ability to look at data from wearable devices, et cetera, et cetera. So, I mean, like I talked about, there's different scenarios I just thought might be interesting for some people to read at their leisure about how you could evaluate a patient with progressive hypoxemic respiratory failure with COVID. The physician can request a consultation quickly, and the remote intensivist can see. And often, as just one look at the patient, somebody needs to be intubated, right? You don't need a lot of data, right? Okay, you just look at the patient. Okay, show me the patient. Okay, just get ready for intubation. You park your iPad in the room, have the bedside doctor put the back camera on. You can supervise the intubation. So it should be as easy as that. Okay. You can go on to routine evaluations with somebody who's on some, on some vent settings, and the settings don't look appropriate. You can look at the waveforms through your device, through your mobile device. And these cameras are so good. When you zoom in with your cell phone itself, you can actually see the screens pretty darn well. So you can actually look at every setting on the ventilator. And you can tell the bedside provider, the RT nurse, to make the appropriate changes. So that's another potential application. The next thing is, you want to talk to to have some goals of care discussion with patients and families, the application today allows for team-based communications. In other words, you can have a physician and a nurse on the remote end, okay, and a patient on one side, and potentially a family member also on the other side, all participating in a call to talk about goals of care. So that's another potential use case where how the system could be used. And I think these are sort of practical situations which we encounter every day, but just to show that all this is possible, with using this sort of system. I think that the team-based communication is important. The application itself actually has different roles in it. So when you log in, you can be a remote doctor, remote nurse, a remote pharmacist, remote respiratory therapist, or an APP. So there's all these roles that when you log in with the credentials. So when a bedside provider is talking, he's talking not to just to the doctor, but to a remote team. So a team of doctors and nurses. So even if the doctor is busy, or maybe it's a bedside nurse that wants help from an experienced critical care nurse. So then having that team approach allows this type of fairly structured communication to help troubleshoot and figure out how to help situations. I think this is also important because, as we've seen the pyramidal staffing scheme, it talks about having an intensive, sort of a pyramidal scheme where, the most experienced providers are at the top of the pyramid, and then, you have, APPs with higher ratios and nurses with even higher ratios of patients. So I think having, if you will, hardwiring that pyramidal scheme by building in the appropriate technology tools can help with implementing that sort of staffing scheme. The other thing, of course, I talked about is, communication between, again, the similar thing is about talking between team members about appropriate goals of care for patients and helping troubleshoot problems on patients. And I think these are just more, descriptions of how you may actually implement such a scenario. And again, we have to remember that in many cases, you would be offering support to facilities without any prior intensivist coverage or insufficient coverage. So there's a hospital, is it a smaller hospital? You just put somebody on oxygen or high flow you've never done in your life before, you don't know what to do. And you do it under the guidance of a remote expert that you would be able to access through this application. And again, I talked about the rapid onboarding. So we mentioned this idea of a dynamic or a scalable network of intensivists. So the idea that you'd be able to recruit additional intensivists fairly rapidly through such a system. Of course, one big caveat is that, you're assuming that states are going to allow emergency practice, licenses in place, and hospitals are not going to follow their rather arduous processes for credentialing and licensing. So, I mean, obviously, because that is always a bottleneck to scalability, and we'll talk about that as well. But having an application-based capability to just sign up is big, right? As opposed to waiting for a locums company to tell you, there's openings here or there. As opposed to that, you get notifications saying that you're wanted. That would be a much more organized way of doing this, especially in pandemics. I think we all saw that it was a cluster in New York where hospitals really struggled to find doctors. It was all kinds of combination of locum companies calling you at random hours versus ads in the in the internet, and SCCM sending Hail Marys, and it was just a cluster, right? So because there was no system. So I think so having a system like this would certainly help streamline this. And again, the vision here is to pre-vet a sufficient number of intensivists and specialists in the network so that they're already on standby mode. Okay, so that is how the vision of the system is, that we already have a number of doctors already vetted and pre-vetted, but the idea is to have that on an ongoing basis so that you always have a ready pool of doctors and nurses who meet certain minimum requirements and are available to be onboarded and rapidly provide support when needed. If that makes sense. So, so obviously this all sounds great, but there are some real barriers we have to address, right? So I think one of the biggest barriers always is regulatory. I think much as we recognize the need for a national response system like this, there are huge barriers at a state level, at the hospital level. Hospitals, they are desperate, they need help, but the credentialing people will just not
Oh my God.
ease up. They will not let go of that, oh no, I need your high school 8th grade diploma, Uh, so I mean, so I think that's the practical that's the practical side, right? So and we've seen this in action. In fact, right now we're dealing with a very small institution that needs help, but their credentialing process is so unbelievably slow that the COVID's going to come and go long before they get their help they need,
Oh my gosh.
So it's just unfortunate that I think there's a huge disconnect amongst different parts of the healthcare systems between urgency and what it takes to respond to urgency. So that's that. And states, I think many states did step up very quickly. New York, Minnesota, Texas, they all eased up. They signed executive orders and said anybody, with a license can practice. But I think it needs to just we need to have a system in place for that to happen in a more streamlined fashion in the future. Now, technology can also, obviously, as a barrier to scalability. Obviously, you mentioned something about connectivity, right? So there's that. But I think as we go along, we will be able to address some of that. The other thing is, I think this system is essentially, it relies on a very simple mobile-based interface, right? But hospitals want to repurpose existing hardware sometimes. And so that's not scalable, right? So there has to be a willingness to sort of adopt different types of technology. So that's what I meant by reliance on existing hardware systems. Yes, we can. It's possible to interface a system into a telemedicine cart, but it's not like plugging something into a socket. Technology doesn't work like that, right? So it's not that easy. So I think there's to be sort of a different mindset when you think about this situation. The other thing is, of course, dependency on EMR for everything. So a system like this is not going to work if you're going to mandate that your physicians have to log into the EMR to put every order in, right? It's not going to work, right? So this is meant to be a fluid, rapidly, just-in-time support model. So there again needs to be sort of a thinking in a different way about what this situation is. I will put this here at number 4. It's probably number 1 because hospital IT systems. I don't know how many of you have seen this, but typically a security questionnaire is about 250 questions or more. But I think, and that's why I think the system has been stood up or developed to hopefully address that, so that when they say the government has come up with a solution that is already HIPAA compliant, it checks all the boxes. So please don't give them 300 questions to answer. Just let the hospitals use the system. Okay. So I think that's but that's the reality we have to recognize. Now, financial barriers are significant. Obviously, I think physicians and clinicians in general, I mean, we are very willing to step up, but after a certain point, people will expect some sort of incentive. There has to be some sort of compensation for people's time. So I think the government has recognized that, and there's some discussion about how that funding might actually happen to support, clinicians' time, and of course, liability. Despite the urgency of COVID and everything else, there's not a provision that will absolve the physicians of all liability if there's a problem. So malpractice insurance still has to happen, even if it's an emergent situation. So these are all sort of actual things, barriers. I'll talk about interoperability in the next slide itself. So obviously you mentioned early on that we want systems to be able to talk to each other. Obviously the NetSyn system and the distress system as well will work best if there's interoperability between this system and other systems. So for that, actually, the work is already underway to develop what we call a cross-platform application module. The idea is that this would coordinate the telecritical care response across the country between different groups of vendors, even potentially. So this is initially going to involve developing a prototype or a minimum viable product, where we would test the ability of one telecritical care solution to communicate with a different type of telecritical care solution. So the idea is to provide an MVP infrastructure necessary to seamlessly and collaboratively deliver information between different telecritical care systems, each operating on their own, but yet sharing data with each other. So foreseeably, I'm providing support to Hospital Texas, and I'm overwhelmed, and suddenly I want to hand off my entire pool of patients to a system in Maryland. I should be able to do that, right? So the idea of the CPAM is, if you will, is to sort of enable an infrastructure that will help that happen. Obviously, it's not a trivial effort at all, but it's something that the work has already sort of begun for that. And I think that's my last slide. So I will stop there, and any questions or any clarifications, I'd be happy to take that.
Well, Dr. Subramanian, thank you very much for this presentation, and congratulations on having a flexible and innovative solution to a problem. And I hope this will never happen again, but this is something that could happen in the future. And I'm already seeing a wide application of this solution when it comes to shortage of intensivists, used in third world countries wherein there's no intensivists. Also used in emergency or disaster, global ICU, and staffing issues. So right now we don't have any question in the chat box, but any comments from the crowd right now? Well, I'm not seeing anything, Dr. Subramanian. So thank you very much, for gracing us with this talk. And we will have this recorded and available for everyone in the future.
Sure. If you need the slides, I'm happy to send those across as well.
Yes, sir. That will be great. Thank you.
Thank you so much.
Okay,
Pleasure.
thanks everyone.
Bye-bye.
Bye-bye.